Hi, calculus students. We're here doing section 7.2, verifying solutions for differential equations. In this section we have if dy dx equals y times cosine x. So the first thing I notice here is that we have a function of y times a function of x. And that usually leads to separation of variables. So we're going to separate the dy and the dx. We're going to say dy over y is going to equal cosine x dx by multiplying both sides by the dx. And then we're going to integrate both sides, and the left hand side gives me the natural log of absolute value of y, and then my right hand side gives me sine x plus c. Can't forget the plus c. We have the initial condition that y is 10 when x is 0. So we can put 0 in for the sine, and sine of 0 is 0. So I get c. Then put 10 in, and I get the natural log of absolute value of 10, which is just the natural log of 10. So we do have a value of c to be the natural log of 10. So writing down our natural log of y statement again, we can write this as natural log of y is equal to the sine x plus our c that we just solved for, which is the natural log of 10. We're going to exponentiate both sides, and then we're going to write down absolute value of y is going to equal e to the sine x plus the natural log of 10. Now we could leave it like this if we wanted to with the natural log of 10 in the x opponent position, but we're going to clean it up a little bit. So we should have that we have the absolute value of y is going to equal e to the natural log of 10 multiplied by the base e raised to the sine x. We can do this because when you multiply like bases, you add exponents. Therefore, if we're adding exponents, we can write it as a multiple of like bases. So e to the natural log of 10 is clearly 10. So we have 10, because e to the natural log of 10 is 10, times e to the sine x. And this represents our absolute value of y. So we only have the positive version, because when we have 0 going in, we should have a positive 10 coming out. So we can drop the absolute value at this moment and leave it as a positive 10. So my final answer is simply 10 times e to the sine x.